In this video, we're going to learn how to calculate effective rates of return. So suppose you have $1,000 and a bank offers to pay you 3% annual interest on a savings account with interest compounded monthly. So what annual interest rate do you need to earn the same amount at the end of the year if the interest is compounded annually? So what this means is 3% isn't just, you don't just take 3% of 1,000 and put it on top of the amount. You're actually earning more than 3% by the end of the year, which is what we're looking for, is what rate is actually happening here when you compound monthly. So the best way to calculate this is first to see how much is in the account if you compound it monthly over 1 year. So we're going to use the compound interest formula I wrote down here, where we're going to look for the future value whenever our principal is 1,000. 1 plus our rate is 0.03. And our compoundings is monthly, so that'll be 12. And to the 12 times 1, because you want to know what's the same rate you would have at the end of the year if you compound it annually. So we're just going to do it for 1 year. So I'm going to plug in all of this. So 1,000 times 1 plus 0.03 divided by 12, all raised to the 12 times 1 power, which is just 12. And we get $1,030.40, let's say 2 cents to round up properly. So how much interest did we make just now? The interest I made on this was $1,030.42 minus the original $1,000, which would be $30.42. So that's how much interest I made. If I want to calculate what percentage of the original amount was added on to it, I would take to find that effective rate of interest is what we call it. We take the interest amount and we divide it by our principal. And our principal in this case was $1,000 is what we started with. So we'll take $30.42 divided by $1,000. So $30.42 divided by 1,000. And we get 0.03042, which that rate is approximately 3.042%. So it's a little bit more than 3% is what the effective rate of return is. Now, in case you didn't understand where this formula came from, that just came from the simple interest formula. I is equal to principal times rate times time, where we're going to assume time is equal to 1. So I is equal to P times R, and we're going to find that simple interest rate by just dividing by P. So R would equal I over P. Now, this was a multi-step process, but really, we can rewrite one of these formulas to exclude P and just tell us how to find just that rate without having to worry about finding the future or the present value. Because how we found this interest rate, if I go back a previous step, that came from the future value minus the present value, the principal. So essentially, the effective rate of interest is equal to the future value minus the present value, all divided by the present value. So R of E is equal to A over P, the future over the present, minus P over P, which is 1. So if I wanted to create a formula for this, I would have to divide this formula by P and set T equal to 0. T equal to 1. So if I set T equal to 1, it goes away. So it's just to the n power. And if I divide by P, P also goes away, and I'm left with RE, which is the effective rate of return, is equal to 1 plus the rates over the number of compoundings to the number of compoundings, and then minus 1. And I can do the same thing for continuous compounding by just dividing by P and setting T equal to 1 to get that the effective rate of interest would be equal to E to the R power, because T is 1 and P has been divided out, and then minus 1. So I have these nice formulas just to find that rate. And knowing that rate lets you know really how good that interest rate is. So let's look at this next problem. We're actually going to use this technique to figure out which deal with which bank would be best for us. So suppose you want to open a money market account. You visit 3 banks to determine their money market rates. Bank A, which I'll write down here to keep track, offers you 6% annual interest compounded daily. So 6% compounded daily, which would be 365 days in the year. Bank B offers you 6.02%, but compounded quarterly, so it's a higher percentage but compounded less times in the year. And then Bank C, which offers you the lowest interest rates, 5.98%, but it's compounded continuously. So it's like the most compoundings you can possibly get. So amongst these percentages, one of them is better than the rest. But we're going to calculate that using these formulas. So for Bank A, R sub E, the effective rate of interest, is equal to 1 plus the rate, which is 0.06, divided by 365, raised to the 365th power minus 1. So let me plug that in and see how much that's worth. Oop, covering it up. So parentheses 1 plus 0.06 divided by 365, all raised to the 365th power, and then minus 1. And that gives me the effective rate of interest to be approximately 0.06183, which can be written as 6.183%. Now let's look at Bank B, where its effective rate of interest will be equal to 1 plus the rate, which is 0.0602 over 4, all raised to the 4th minus 1. So R sub E there would be approximately 1 plus 0.0602 divided by 4, all raised to the 4th power minus 1, which is 0.06157, which is approximately 6.157%. And then to do it continuously, the effective rate of interest will be E. So I'm covering it up now to the 0.0598 minus 1. So E to the 0.0598 minus 1, which is approximately 0.06157 62 is approximately 6.162%. And if I had to rank all my percentages, my lowest percentage happens to be from Bank B. My middle percentage happens to be from Bank C, but my highest percentage rate of return would be from Bank A, which is 6.183. So that came in first. So which bank is giving you the best deal? Well, that will be Bank A. And over time, any advantage or any bigger rate that you can possibly get in terms of savings is always the better choice. Vice versa, if you're having to pay interest off on like a loan, you want the lowest possible. But in this case, since we're trying to make money over time, we want the highest rate we can possibly get. And that is how you calculate effective rates of return.